Okay, we will continue our lesson on points, lines, and planes, and we'll talk about a thing called the postulate. So let's define what a postulate is. A postulate is a rule that is accepted without any proof. The reason postulates are accepted without proof is because everybody agrees with them, kind of like a defined term. They are basically common sense rules that anyone can figure out without being told the rule beforehand. So for example, I'm not going to tell you this rule, but I'm pretty sure you can probably figure it out. Before I give you the answer, maybe you might want to hit pause. But this first postulate is called the 2 points postulate. And it says that through any 2 points, there exists exactly blank line. Okay? How many lines do you think exist through this? Now, not many people are going to argue. Most people are going to agree that there is exactly only one and only one line. Like that. Okay? If you try to draw another line through the point, it's not going to go through the other point. Or if I try to go through the other point, it's not going to pass through that second point. So the only one line that exists would be this line and that line only. Okay? So the answer here would be 1. And if you draw a line through here, that's basically all I want you to put there. That through any 2 points, there exists one line. You might not see a line, but there exists. That's a key word, that there exists. And if you remember last lesson, we had said that points exist anywhere. You don't have to draw them all, but they're all over the place. And therefore, that line exists there. The second postulate is called the 3 non-collinear points postulate. And if you remember, collinear means on the same line. So non-collinear means not on the same line. Take a look at those 3 points up there. Well, this postulate says through any 3 non-collinear points, there exists exactly blank plane. Okay. Well, how many planes can you draw through 3 points? And the answer would be 1. Okay, but let me show you why, because a lot of people have a hard time with this one. But let's pretend that I have this box here, this 3-dimensional box. And let's say I pick this point. That's 1 point, and I pick that point, that's 2 points. So my third one, I'm going to make it so that it's non-collinear. And so I'm not going to pick any point on this line here. But let's say I pick a point over here on this opposite corner here. Can I draw a plane going through these 3 points? Yes, I can draw a piece of paper that kind of goes from here. Slanted, the piece of paper goes slanted going down this way. And if I draw a plane kind of going diagonally, okay, then that plane will contain that point, and that point, and that point. So through any 3 points that are non-collinear, there exists a plane. And I'm going to give you another example because some people have a hard time with this. But no matter what 3 points you pick, I could even pick this point, that point, and let's say I pick a point up here. Okay? Well, then I can draw a plane, kind of a piece of paper, a flat surface. If I draw a diagonal flat surface kind of going this way, then this plane will contain this point, that point, and that point. So through any 3 non-collinear points, there exists exactly 1 plane. So go ahead and draw that on your picture. Okay, and now intersection. The intersection of 2 geometric figures is a set of all points that the figures have in common. Okay, so when you see 2 shapes, we're going to call the intersection, all the points that they have in common is going to be the intersection. Where do they cross? Where do they meet? Okay, that is called the intersection. And these next 2 postulates have to do with intersection. So the first postulate here is it's going to be called the intersection of 2 lines postulate. And it says if 2 lines intersect, then their intersection is exactly. But before I tell you this, let's just go ahead and look at the picture. What are all the points that this line here and this line have in common? Well, if you look at this point, it's only in the top line, but not this bottom line. But which ones have in common? Well, you can it's kind of common sense. It's obvious that the point's going to be right there in the middle. That is the point where they intersect. So 2 lines, if they intersect, then their intersection is exactly 1 point. Now, the intersection of 2 planes postulate is going to tell us that if 2 planes intersect, then their intersection is a what? Now this one's a little bit harder to see, but if you kind of look at the classroom, if you look to the front wall where you have this chalkboard, and if you look at the ceiling, we have 2 planes, 2 flat surfaces that meet. Well, where do they meet? Well, if you look, they meet at this line going across this way. So whenever you have two planes that cross, they're gonna meet, or they're gonna have an intersection of a line. Okay. Now, this one is a little bit hard to draw. So I'm gonna show you the picture how it looks like, but a lot of people have a hard time drawing this. So I'm gonna do is I'm gonna let SpongeBob explain to you how to draw this shape in this next slide.
First go like this. Spin around, stop. Double take 3 times. 1, 2, 3. Then pelvic thrust. Woo! Woo! Stop on your right foot. Don't forget it. Now it's time to bring it around town. Bring it around town. Then you do this, then this, and this, then that, and this, and that, and this, and that, and then...
Of course, that was just a joke. Let me show you how to do the right way, so you don't have a hard time drawing these two planes intersecting. What I like to do is I like to split it up into pieces. First, I draw a plane, kind of like so, and then from here I'll draw the other 4 planes, because if you notice that when 2 planes intersect, it kind of looks like there's 4 planes kind of meeting in the middle. But after that, we're going to draw a plane going to the right like so. And it's kind of piggyback off the first plane. Okay? And then after that, you're going to continue with like these 2 planes that are going to go on forever to the left and down to the bottom. Okay. So for example, that white plane that can kind of continue to the left, you're not going to be able to see this black dotted line because it's behind that black plane or the dark plane, but you can kind of extend it. So imagine that as like a 3rd parallelogram or a 3rd plane. And then if you want to continue that dark plane going down, well then I can continue by kind of drawing this line over here to signify, hey, I cannot see that, but it's behind that white piece of paper. And it continues downward to the bottom. Okay? So now some people might still have a hard time, so if you want to go ahead and rewind it and put pause, because I know I did go a little bit fast, but it's because I know you guys have the ability to pause, and it shouldn't be that hard to pause it and do it step by step. But go ahead and draw that right there, okay? Points in a line postulate. So this one says that if 2 points lie on a plane, as you can see in that picture up there, then the line passing through those 2 points also what on the plane? Okay? So I'm going to draw a line, and you guys go ahead and draw this line too. But what do we know about that line in that plane? Well, if the 2 points are on the actual piece of paper, then that line that you drew through those 2 points also has to be, or has to lie on that plane as well. Okay. Once again, this is just common sense. We don't really have to prove it, and people just agree that this is the truth. Okay. That's why these are called postulates. We don't have to prove that the line is also going to be on that paper or that plane. It's just gonna, everybody agrees that it is. Okay. All right. For example, a little bit about intersections. It says, where does, and then last, what am I trying to say? The last lesson we learned what that symbol meant. And whenever you see those 2 arrows, that means line. So you will read this as, where does line KL and line QP intersect? Okay. So let's look at the picture. And KL is a line kind of going this way, passing through K and L. And QP is a line going through Q and through P, this line here. And where do they cross? Well, the point that they have in common is J. Okay. So that's the answer here, point J. You don't have to write the word out point, but if you want to, you can. But J is enough. And then here on example B, it says, where does, remember, when you see a bold like that, it's talking about plane. Okay? And you can also see here in the picture, S is the dark plane, and R is the white plane. And where do these 2 planes cross? Well, our postulate says that 2 planes meet at a line. Okay? And which line do they meet at? Well, you can kind of tell that this line MN, or you can call it MJ, or JN, whatever you want to call it. I'm just going to pick M and N. They intersect that line MN. Okay? So make sure you do your notation correct. Do not put a segment. Don't put ray, because the postulate says that 2 planes meet at a line. So make sure you put those 2 arrows. For example C, it says, which points lie on the intersection of S and R? Okay. The ones that you can see here are M, J, and N. These are the 3 points that have names that are the intersection of those two planes. Now there are a lot more points, but they're just not named, so we're not going to make names. We're just going to use the ones that they give us. Okay? And then it says, does line ML lie on plane R? Okay? So plane R is right here. Okay? It's a white plane. And does line ML, now even though you might not see a line going through M and L, there does exist a line that passes through M and L. And so if that line passes through ML, would it be on plane R? Well, the answer would be yes, because according to the postulate we just talked about right now, it says that if 2 points lie on a plane, and they lie on this plane R, then the line going through ML also lines on plane R. So the answer would be yes. Okay? Even though you don't see the line, there does exist a line. All right, example 2. Now we're going to work not just on answering questions, but working on sketching or also drawing stuff. Okay. So for example A, it says sketch a plane and the line intersecting the plane at one point. Okay. So to draw a plane, once again, that's a flat surface. I'm just going to go ahead and draw like this slanted rectangle. That's a plane. And I'm going to draw a line crossing it or intersecting at one point. So I'm going to draw just a random point here in the middle, and this is the point where my line's going to cross. Okay. So now the line cannot be on it. I'm going to draw you an example here. It cannot be on it like that because it's intersecting at every single point. So then to intersect it going, it's kind of just imagine a pencil going through a piece of paper where the line kind of pierces the paper going like that. And then here you were not going to be able to see the line, but it will continue going this way. And that is a plane, or sorry, I should say a line intersecting the plane at one point. For letter B, it says sketch 3 lines intersecting at one point. Okay, so let's go ahead and draw that one point. And all 3 lines have to intersect that point. So here is one line. Well, I should say that's a segment, and that's a segment, and that's a segment. How can we make them lines? Well, we need to put arrows. Okay? We need to put arrows to make that a line. This one is going to become a line, and that one becomes a line because lines go on forever. For example C, it says sketch 3 lines intersecting at different points. Okay? So now, same thing, but instead of intersecting at one point, we're going to intersect at different points. Okay? So if I do 2 lines going like that, well, my third line cannot cross through there because then it's going to intersect at one point. So I can just draw a random third line like that, and these 3 lines intersect at these 3 points, which are different. Okay? So that's basically all you have to do right there. For D, it says sketch 4 rays that do not intersect. Okay? And so, big mistake, I'm going to draw this wrong first. Do not copy this down. But some people might do something like this and say, hey, look, those rays are not intersecting. But you have to remember that this ray, excuse that telephone, but you might think those rays are not intersecting. But you have to remember that these arrows represent that this is going on forever. So yes, this does continue like that, and it will cross. Okay. So in order for me to draw 4 rays that do not intersect, I just gotta make sure that even if I were to continue going on forever, that they will not intersect. And you do have to put the endpoints, and you do have to put the arrows to signify that they are rays. For example E, it says sketch 4 non-collinear points. Remember, non-collinear means not on the same line. So as long as I just kind of draw them, that I cannot draw a line through them, they'll be non-collinear. And we're going to label them A, B, C, and D. It doesn't really matter which direction you make them in. Which order. So I'm going to go like that. And then it says sketch segment AB. So remember, segments, they don't go on forever. They have 2 endpoints, the endpoints being A and B. Ray CD. So a ray, this one is signifying that it starts at C, going towards D forever. So I'm going to go like that. Remember, this goes on forever. And then BC, this part will be a line with the 2 arrows. So I can just make sure that when I draw my shape, that I can continue my line in both directions forever. And then it says, where do the figures intersect? And it just depends on how you drew it, but the way I drew it, they intersect at B. I'm going to write this out. Intersect at B and at C. Okay. And then for example F, it says sketch 2 planes A and B that intersect at line XY. Once again, sometimes you might not see the word line, sometimes you might see these little arrows on top of the line. But we're going to draw two planes that intersect the line, then draw points E on plane A and then point F on plane B. Okay, so now once again, I'm going to do it again, but you can draw a slanted rectangle like so. And then off of that one, I'm going to piggyback this way. And then I'm going to, excuse my picture, but it's kind of hard to draw with this pen that I have. Okay, so I need to draw that they're crossing that line XY, so I'm going to just call this point X. I'm going to call that point Y. And then I'm going to draw, I'm going to call these plane A and plane B, so I'm going to call this one plane A. I'm going to call this one plane B. And then it says draw point E on plane A. So I'm going to put a point down here and call this E. And then I'm going to say draw point F on plane B. So on this plane, I'm going to put a point there and call it F. That's pretty much it. And that concludes lesson 2, continuation of point lines and planes.